This is a video on how to multiply like bases. So the general rule is if you have a to the m power times a to the n power, the a's are the bases. And since the a's are the same, the bases are the same, you can take the two exponents and add them together. Now I've got several examples to go through here just so that we can kind of learn how this works. So we have 3 as a base, and we have exponents of 1, 1, and 1. So we would get 3 to the third. Now since that's just a number, 3 to the third power, 3 times 3 times 3 is 27, and I would be done. Next problem. We have 2, we have 4, and we have 3. The only two that are like bases are the 3's. So 3 to the first times 3 to the first, which would be 3 to the 1 plus 1, or 3 squared. And we'll put the other two numbers out front. And that's really 8. 2 times 4 is 8. And then 3 squared is 9. So the only place where I'm really applying that property is when I'm adding the 1 and the 1 here to get the 2 there. Again, same base, the x is the base. 3 plus 9 be x to the 12th. Here, same base. The exponents are 10 and negative 3. So I have 10 plus a negative 3, which is the same as 10 minus 3. Oops. Which could be y to the 7th. It starts to get a little bit more complicated down at the bottom here. When we have a number here and a number there, we can just multiply those together. And then we're going to put the x's next to each other. When there's no exponent above the x there, it's really a 1. Same thing when this y is without an exponent, it's a 1. And I really like putting the like bases near each other. Makes it a little bit more clear. So the 36 is just the 9 times the 4. X to the 5th times x to the 1st would be x to the 5 plus 1, which is 6. And then y to the 1st times y to the negative 2. I'm going to add these two together. I'm going to get y to the negative 1. And that's the application of that rule. Now, if you know a little bit about negative exponents, then this piece is really 1 over y to the 1st. And then each of the other components would be over 1. So I'd have a y in the denominator on that one. Here we have 10, 3, and 7. Those are my coefficients. So if I did 10 times 3 times 7, that's 210. I've got x, x squared, and x to the 10th. Looks like a 6. Let's do that again. And then we've got y, y to the 5th, and then y again. And then we have this random z to the 4th here. I've kind of color-coded things. We've got our coefficient, that's 210. I've got the blue x's here, that's 1 plus 2 plus 10. So the x to the 13th. We would have y to the 1, y to the 5th, and y to the 1 for y to the 7th. And then the z to the 4th would just kind of be waiting to be kind of part of the final answer. Done.